Hey 8th graders, today's lesson is 2.3 and 2.5 chemical reactions. In your learning targets for today, I can model how atoms and reactants rearrange themselves in a chemical reaction to form new substances with different structures and different properties. So a couple lessons ago we added some new vocab to our OneNote. Product, reactant, and chemical reaction. Those are three really important terms that we're going to use a lot more in this unit, including today. So even just looking at a learning target, you guys can see reactants in there, chemical reactions there, and products, okay? So when we're talking about chemical reactions, and we'll start digging into this a little bit more, there's a lot of different types of chemical reactions. If we take, for instance, one reactant, we could break that down and decompose it into multiple products that have a different atomic structure or different atomic makeup than that one reactant. Or we can do the opposite of that reaction. We can have two reactants that come together to form one product. Or we can just have two reactants that kind of rearrange all their atoms to form however many, however many products that we see in that reaction. Again, they'd all be rearranged and look different and have different properties. So that really is going to be our focus for today. We're really going to zoom in on looking at what happened with Westfield's water, and then you guys are going to do a little experiment at the end of today to see if you guys were right, in fact, that as to how you guys got to the rust formation in their water, okay? All right, so whether you guys are sitting in class or not, or you guys are sitting at home, I'm going to walk you guys through this. Remember to pause after each activity, and then you guys will have some time to finish that activity up with those instructions fresh in your brain, and then we can move on to the next activity. So as you came into class today, you guys should have already completed the activity 2 warm-up. What have you learned so far about how new substances form? List your idea below. So you guys want to obviously talk about maybe how you know a new substance is formed, but the main thing that you're addressing here is how does that new substance form? Where does it get the things it needs to make a new substance? And how does that process look? So you guys have already done a lot of little chemical reactions in class to see that. Okay, if you guys need a second longer to finish your warm-up, go ahead and pause this now. If not, we're going to move on to activity 3. All right, activity 3 is a little hands-on, okay? I like doing the online sorting tool better than I like doing the little tokens, so it's really not so much hands-on, so much as you guys are going to be building these and testing claims in that sorting tool that we've used so far already in 2 lessons. Okay, so you guys got a little letter from the lab from Samara Young. I hope you've been making progress in your investigation since my last message. Today, the people of Westfield are expecting a report that explains how the rust in their water formed. Hey guys, a little note, I'm not going to make you write a report. Okay? To complete this report, you will need to use everything you have learned so far about how substances change into different substances. For your reference, we are listing the claims below. So if you guys remember our 3 claims of where the rust came from, the first one was the iron pipes changed into rust. Claim 2, the fertilizer changed into rust. Or claim 3, the iron pipes and the fertilizer changed into rust. So first and foremost, we're going to be looking at that sorting tool to explore each of these claims and to see what would happen on the atomic scale if any of these claims are even possible. So good luck. We look forward to reading your report. Not going to happen. All right, so hands on. This is your little sorting tool that you guys will be doing today. So testing the claims with a partner, use the tokens. Again, we're going to be using the tokens in the sorting tool to test each of Dr. Young's 3 claims. Discuss whether the atoms of the substance or substances in each claim could possibly rearrange to form rust. Again, I'll show you guys the first one on this so you guys will have an idea. Those of you guys sitting in class, obviously, if you haven't already, you need to make sure your laptop is facing forward. Then complete the sentences below, recording whether or not you think each claim is possible. So you guys can right-click here in a second and open up this link. Looks a little something like this, should be familiar to you guys. But I'm going to go ahead and do the first claim for you. So if you guys remember again, the first claim says the rust formed from the pipes. Okay, so in the sorting tool, build your reactant. So remember we did this, you guys only built the reactant and then you guys rearranged that reactant to see if you could form the products. That was from a couple lessons ago. We're going to do the same thing to test these claims. So in claim 1, the pipes are the only reactant. Try to rearrange the tokens from the reactant to form the product below. Okay, so we know my only reactant is this iron pipe, so I'm going to go find iron over here. Here's my kind of little orange iron, and I'm going to drag it over here. I'm going to take a look at my product and see what my product looks like. So it looks like my product has 2 irons, so I'm probably going to need to add a little bit more reactant, at least another iron. Now we have 2 irons available. Okay, let's go back to our product. My product also has 3 oxygens, but it's not part of my reactant. So if I go in here, I can't add oxygen in here because the claim states that the iron in the pipe is the only reactant. There is nothing else. So there is no oxygen available here. So I could take these 2 irons and put them over here to make a product, but there is no oxygen, and I can't just pull in oxygen for this product. Okay, we're going to talk a little bit tomorrow about law of conservation of matter, which says matter can't be created or destroyed. So if our reactant, the only reactant we have is iron, okay, the only thing that we should have in our product is also iron, okay? We have iron, but we don't have oxygen available, so it's not just going to appear out of nowhere, okay? Our only reactant is iron. So even if there's oxygen in the water, it's not reacting. It's not part of our reactants because our only reactant was iron. Okay, so that right there tells us claim 1 is certainly not correct. Okay, so I would say, could the rust have formed only from the pipes? And I would use my draw tool and say a big old fat heck no. Okay, explain why or why not. You guys can type your answer there and say, well, the product has iron and oxygen, and if our only reactant was iron, we don't have oxygen available to make our product, so it can't be claim 1. Okay, you guys are going to do the same thing on claim 2. Remember that claim 2 says that the only reactant, again, we can't steal from anywhere else. Our only reactant was NaNO3, which is the fertilizer. So you guys would do the same thing here. You guys can reset your sorting tool. You can build this NaNO3. So start with sodium. You need 3 oxygens. Here's my sodium here. I need 3 oxygens. And a nitrogen. Okay, so there's my reactant there. Okay, so if I look at this, now I need to rearrange only the N, the O, 3 O's, and the Na, the 3 O's, and the N to form Fe2O3. I can't talk today. Okay, so can that happen? Can I rearrange these to form this product, Fe2O3? Okay, so go ahead, finish that up, look at claim 2 and say, can I make Fe2O3 out of NaNO3? Explain why or why not. And then finally, you guys will test claim 3 in the sorting tool. Build your 2 reactants. So this is the only claim that has 2 reactants. You guys have both the iron pipes and the fertilizer NaNO3. Okay, so in claim 3, the fertilizer and the pipes are both reactants. Try to rearrange the tokens from the reactants to form the product below. So do that in the sorting tool and then answer these questions. Could the rust have formed from the fertilizer and the pipes? Circle yes or no, and then make sure you guys give a good explanation as to why or why not. Okay, so go ahead, pause this video right here to finish up activity 3, flip your computers around, and complete this part right now. All right, moving on, you guys are going to be working on activity 4. We're kind of slowing down for the day. We have one more activity in here, then we're going to do a little experiment, and then you guys will be done for today. Okay, so you guys are going to do a little modeling for this, modeling how the rust formed. Use the modeling tool, how the rust formed sheet, to help you explain to the people of Westfield how the rust in their water formed. Your goal is to make a model that explains how the iron pipes and fertilizer changed into the rust. So at this point, you guys should have found out that claim 1 and claim 2, there's no way you guys could have made Fe2O3. Okay, in claim 1, your only reactant was iron. You didn't have the oxygen available to make Fe2O3. Okay, on the other hand, with claim 2, you guys had NaNO3. You had the oxygen available to form the Fe2O3, but you didn't have any iron available because fertilizer was the only reactant. Okay, so that leads us to Fe2O3, or excuse me, our claim 3, where we had, if I go ahead and clear this out and look at it, you guys should have done something that looks like this. We had some iron as our reactant. And then we had the NaNO3. Okay. And then we can look and say, all right, we need to make Fe2O3. So here's our 2 Fe's that we can rearrange. And then our 3 oxygens that we can rearrange. Okay. So can we form Fe2O3 from the fertilizer plus the iron? Yes, it is right there. Notice how I didn't have to come over here and add any atoms to form this product. We got it all from what we had on our reactant side. Okay, so claim 3 is obviously correct, and now you guys are going to draw a model to kind of show how that formation happened. So in the before space, draw the iron pipes and fertilizer before they changed into rust. However that looks for you guys, I would maybe do it on an atomic scale similar to what we've been doing where you guys draw circles and maybe label them. In the after space, draw the rust. In the during the change space, draw or describe how the iron pipes and fertilizer changed into rust. Label your model or create a key. So that's where you guys are going to want to talk about how those atoms rearrange themselves. So again, I would do this all on the atomic scale, but if you guys have a different idea on how your model works, that it's absolutely up to you. It's your call on how you represent this process. Okay, label your model or create a key. So there's a little box there for you guys' key. And then some tips, use the substance reference guide provided to you, and you can draw more than one repeating groups of atoms for a substance is needed. So basically that's saying you're going to need more than one iron atom, otherwise you're not going to be able to form rust because you need at least 2. All right, so looking at this then, here's your substance reference guide so you guys can kind of look. This is iron, it's gray, solid at room temperature. It's made up of repeating atoms of Fe. This one's your fertilizer. This is repeating molecules of NaNO3. It's white, solid at room temperature. And then finally, rust is repeating groups of Fe2O3 or repeating molecules of Fe2O3. So it's brown, solid at room temperature, so on and so forth. So here's where you guys will actually draw and build your model. So you guys need to make a key on how you guys did this. Do your before, what did everything look like before we had a reaction? What was the after? And then finally do the during the change. Describe or draw how the iron pipes and fertilizer changed into rust. So here we go. Right here is your little instructions on how to complete this. Okay, go ahead. You guys can flip your computers around now, pause this video, complete your model, and then when you guys are all done, flip your computers back up front, and we can move on to the last little activity in this lesson. All right, activity 5 is an experiment. So you guys are going to be broken into groups of 4. Okay, if you guys don't have enough to form a group of 4, then you guys can go ahead and do, maybe if you need to do 2 groups of 3 or a group of 2, if you guys are cool with that. Here's your guys' partner responsibility. So everyone has a responsibility in this, whether you guys have a group of 4 or you guys have to kind of share extra duties and just do a group of 2 or 3. Okay, so partner 1, you guys will come up front and you guys will measure out 0.5 grams of iron. So this is pure iron. You guys got to observe it in those little vials the other day. And then just as a reminder, when you guys are weighing that, you need to be in grams. So you should see a little G up in the upper right-hand corner of the scale. If it's not on G, make sure you guys press mode until it goes to G. Okay? You guys will have a clean weight boat. Place your weight boat on the scale. Hit 0. So we're not weighing the weight boat. We're just weighing the iron. And then once your scale is at 0, you guys can slowly add a little bit of those iron filings until you guys have exactly 0.5 grams. If you go over, you need to take and scoop some of those back out into the container. Okay? Once you guys have that done, you guys will bring partner 1, you guys will bring that back to partner 4, and they will dump it into their little cup. Partner 4, I'll get to your job here in a second. Okay? Then give your empty weight boat to partner 2. Partner 2, you guys are going to do the same thing. Make sure your scale is on grams. Hit mode until it's on grams. Make sure your weight boat's pretty cleaned out. Set your weight boat on the scale. Hit 0. And then you guys are going to measure out 1.1 grams of fertilizer, which is NaNO3. Okay? You guys need exactly 1.1. Don't go 1.2 or 1.0. So you guys can kind of add or remove as necessary. And then once you guys have that, again, you'll take that over to partner 4. Partner 4 will add that to their beaker. And then partner 3, you guys will grab your graduated cylinder and you guys are going to measure out about 20 milliliters of warm water. Not too hot, doesn't really matter, but as you guys remember, when we're talking about kinetic energy, the warmer the substance is, the more energy those molecules have, the faster they move. So we'll be able to get our fertilizer to dissolve quicker, and it might even start to speed up our reaction a little bit, although by the end of the day, you guys probably won't see a whole lot happening. We're gonna have to let this sit for 24 hours. Okay, so measure out 20 milliliters of warm water from the tap into the graduated cylinder. Remember to measure to the bottom of that meniscus so your water kind of makes a little curve shape, so the 20 should be right at the bottom of that. Okay, bring that over to partner 4. They will also add that to your cup. And then you guys will need to make observations. So partner 4, as your partners 1, 2, and 3 are doing all of this, you're gonna grab a little plastic cup and a Sharpie. You're gonna label all 4 of your guys' names on the cup. You're gonna add a period number, and then they're gonna bring you the stuff and you're gonna add the ingredients and mix it up. Okay, let's talk observations. Okay, so after the ingredients are mixed, make good observations on this next slide here. Set them on the counter with your designated class period to sit overnight, so I'll let you guys know where you're setting yours. You will not be turning in this assignment today, so do not hand this in with the exception of DLI. DLI, you guys will be able to finish this today. Okay, we're gonna make our observations for what it looks like before our reaction really had a chance to take place right now, and then tomorrow in class, you guys are gonna make your final reaction. Okay, we will make observations tomorrow after it has had enough time to react, and then we'll hand it in. If we are truly forming rust in this, you guys should know that it takes a little bit of time for rust to form. So again, we're gonna get it 24 hours, then you guys will be able to see the results. DLI, watch this video. I'll show you guys the lab setup so you guys can kind of make that before observation. And then once you guys have your before observations, you guys can go ahead and watch the after results right here, and then you guys can finish up this assignment if you're DLI. Okay? So here's where you guys will do your observations before. Again, those of you guys sitting in class, you guys are going to have to wait tomorrow to finish this part right here. DLI, you guys can finish that right now. And then answer this question tomorrow. Could the rust, Fe2O3, have formed from the fertilizer, NaNO3, and the pipes, Fe? Yes or no? And then to finish up today, you guys can complete your wrap up. Any questions, yes or no? If yes, type them below. And how do you feel you did on this assignment? 4, 3, 2, 1. At this point, you guys can go ahead and finish up this video. Go set up that experiment, get it going, make your good before observations. But again, remember those of you guys sitting in class, you guys can't finish this assignment. Do not turn it in until tomorrow when you guys have finished slides 16 and done slide 17 with your results. Okay? Other than that, have a great day. I hope you guys are doing all right without me, and I will talk to you soon.